Mm. Good morning, students. So now we're solving the 2 cross 2 linear systems. So in the previous class, we're solving the linear congruences equations and system of linear congruences equations using Chinese terminology. So now we can able to solve 2 cross 2 linear systems. So the 2 cross 2 linear system is of the form the system of linear congruence ax plus by congruence e modern and cx plus dy congruence f modern. The ABCD are some integer, M is a positive integer. So this is called 2 cross 2 linear systems. So now we can able to solve the system linear 2 cross 2 linear systems. So using the following result, the linear system of congruence 1 has a unique solution if and only if GCD of del comma m equal to the del is the modulus of the coefficient matrix. X coefficient in the first column A and C, and second column is the y coefficient B and D. So take the modulus AD minus BC under modulo M. So this GCD del comma M equal to 1. If it is 1, then the given system has unique solutions. Also, the 2 cross 2 linear systems is solved by two techniques. The one is similar to grammar rule, the another one elimination techniques. So the grammar rule, so using the following steps to check the GCD of del comma m equal to. And next step 2 is find del x and del y. And next find del inverse. Okay, so del inverse congruence 1 modulo. So del x and del y is obtained by, so del x is modulus of, we can eliminate the from the del matrix the x first column. Instead of, we can put right hand side constant EF and second column say B and D. So take the modulus, we can get the del x value. Similarly, del y is, we can eliminate the second columns. Instead of, we can introduce the right hand side constant E and F, and first column same A and C. So take the modulus, you can get the del y values. And step 3, find del inverse using the following linear congruences. Del inverse congruence 1 modulo E. Already we have obtained del value, substitute here. So this product of del and del inverse under modulo M, we can get the remainder. So we can choose the some other values of del inverse. So it will be satisfy the remainder is 1. So instead of, we can choose the values of del inverse, the corresponding value should be exist. So that is the required del inverse value. And finally, step 4 is the solution of 1 is x congruence del inverse del x modulo m and y congruence del inverse del y modulo. Okay, so this is a grammar rule techniques. And next elimination, already you know about the elimination methods. We can solving the any one of the variable x or y, immediately we get the unknown values. So using this unknown value, known values, substitute any one of the same equations, we can get the solutions. So elimination method already you know that. Okay. So now we can see the problems. So solve the system. 3x plus 13y congruence 8 mod 55 5x plus 21y congruence 34 mod 55. Solution is, so first find del value. So determinant of 3, 5, 13, 21. So this determinant value minus 2. 3 into 21 minus 5 into 13. So minus 2 modulo 55. So minus 2 is a negative remainder. It will be converted into positive remainder. So using minus 2 plus modulo 55, adding this, we get the positive remainder 53. So 53 modulo 55. So now check the condition. GCD of del comma m. So 53 comma m is 55. So GCD of 53, 55 is 1. So therefore, it has unique solution. Okay, so now find del x. So del x means determinant of, we can eliminate the x column, introduce the, instead of the right hand side constant 8, 34, the second column same, 13 and 21. So take the determinant 8 into 21 minus 34 into 13. We get the value minus 274 modulo 55. So 274 we can divide by 55. I think so 5 times, 4 times is not exceed. So minus 274. Yeah. So 5 times 27. So minus 1. So already this minus is there. So minus of minus 1 modulo 55. So congruence 1 modulo 55. Okay. And next find del y. Determinant of same x column the del matrix 3 and 5. Eliminate the second column 13 and 21. And instead of the right hand side constant, put here 8, 34 and take the modular determinant 3 into 34 minus 8 into 5. We get the value 62 modulo 55. 62 can be divided by 55 one times. So remainder is 7. So 7 modulo 55. Next to find the del inverse. So using the congruence, del inverse congruence 1 mod 55. So already we obtained del value. So del is 53, del inverse congruence 1 modulo 55. So the 53 is a big value. Also, the 53 is convert into positive remainder. Already we get the negative remainder is equivalent to minus 2. So we can apply it is also possible equivalent. In our problem, we can convenient. We can reduce to negative remainders also. Okay. So 53 into minus 2 del inverse congruence 1 mod m. So now we can choose the del inverse value. We can choose the del inverse value. Among this del inverse value product with minus 2. So this left hand side total product, it can be divided by 55. Then corresponding, we get the remainder as well. So this corresponding del inverse value, it is a required. Okay. So already minus 2 is a negative remainder. So del inverse, we can choose the negative value. So first we can take minus 1, minus 2, minus 3 and so on. Okay. We want to divisible by 55. So we can choose del inverse value more than 1. So I can take minus 20. So minus 20 into 2 minus plus 40. 40 is not divisible by 55. So next we can choose del inverse is minus 25. Minus 25 into minus 2, 50. It's not more than 55. So let us take 28, minus 28. So minus 28 product with minus 2, that is 56. So 56 can be divided by 55. We get the remainder 1. So we get the remainder is 1. So therefore, the del inverse value is minus 28. Okay. So instead of the linear congruence, it must be satisfied. Instead of, we can choose the del inverse value. So that is required del inverse value. Okay. So after finding this del inverse, we can write the solution. The solution of the given system is, the solution is x using the step 4. So x congruence del inverse and del x modulo 55 modulo m. That is modulo m. So del inverse value minus 28 already obtained and del x already obtained 1. Modulo 55. So minus 28 into 1 minus 28 modulo 55. Congruence minus 28 is a negative remainder. The final answer always represent as positive remainder. So minus 28 plus 55, that is 27. So it will get positive remainder 27 modulo 55. So this is the solution of x. Similarly, y is del inverse del y modulo m congruence. Del inverse is minus 28 and del y is 7 modulo 55. Congruence minus 28 already obtained the positive remainder 27 into 7 modulo 55 and 27 into 7 189 modulo 55. Congruence 189 can be divisible by 55. I think so 3 times. So 4. So 4 is the solution of 1. Okay. So therefore the solution is x congruence 27 modulo 55. The solution of x is x congruence 27 mod 5 and solution of y is y congruence 4 modulo 55.